Good afternoon. We'll go ahead and get started. My name is Aubrey Yost. I'm a senior policy analyst at the Schatz Energy Research Center, and I'm pleased to introduce today's webinar, which is titled, What Does It Take to Grid Connect Offshore? Cable Laying and Monitoring at PacWave. The webinar will be presented by Dan Hellin, Director of the PacWave Energy Test Facility, and Sarah Henkel, Associate Director of the Pacific Marine Energy Center at Oregon State University. Before we dive into the webinar, I first want to let you know that this presentation is a production of the Pacific Offshore Wind Consortium, or POWC. POWC is a university-led partnership between the Schatz Energy Research Center, the Center for Coastal Marine Sciences at Cal Poly San Luis Obispo, and the Pacific Marine Energy Center at Oregon State University. Today's webinar is being recorded and will be available online next week on the Schatz Center YouTube channel and at schatzcenter.org/wind. We'll also be posting the video to the POWC website in the next week. If you have any technical difficulties, please post to the chat box and we'll try to help you resolve the problem. Today's presentation will be followed by a Q&A discussion. If you'd like to ask a question, please use the Q&A box at the bottom of your screen at any time. And I'll now hand it over to Dan to get us started.
Thank you very much. Good afternoon, everyone. I'm going to start off talking more about the sort of technical side of the cable laying operations associated with PacWave, and Sarah's going to talk more on the monitoring side. For those who are maybe not familiar with PacWave, we're a wave energy test facility based in Oregon. We're part of Oregon State University, primarily funded by the US Department of Energy. We have two sites off the coast of Newport. We have PacWave North, which is a non-grid connected site, which I'm not really going to be focusing on today. And then PacWave South, which is our flagship site, which is just finishing construction and just about to move into operations. It's got 4 offshore test berths and has 4 separate cables running to shore. So these are 36 kV cables, each capable of supporting up to 5 megawatts of power generation, running to shore and coming ashore at Driftwood Beach State Park. So this is a timeline of the development of PacWave. Both Sarah and I have been working on this and many others for a long time. And I'm going to sort of start early on in this process just to sort of give some background about how we sort of got to the actual cable installation piece. This timeline covers, 12 plus years, actually almost 15 years. And the actual cable installation work was about 2.5, 3 months last summer. But there's a lot that goes up into the preparation and planning, design and engineering, and the permitting for something like this. So going right back to the beginning, when the idea of a grid-connected test site was first being discussed, Department of Energy and OSU decided to look along the Oregon coast to see if there were places where a grid-connected site could be located, and started off by identifying 4 communities, starting with Warrington up in the north, Newport, Reedsport, and Coos Bay. And back in 2011, 2012, OSU, working with Sea Grant, carried out a number of community meetings to try and determine whether there was interest in having a site like this located off the coast of these communities. So those meetings were held, and it was then down selected to Newport and Reedsport. And then those 2 communities put together what were called community site selection committees, and basically put together proposals as to why they would be a good location for PacWave. These committees included a wide range of community members, including stakeholders like the fishermen, tribes, government, members of the public, and of course ports and utilities critical for a grid-connected site. Their proposals were submitted in December of 2012, and in January the following year, Newport was selected as the location of the grid-connected site. We then worked with a committee called the Fine Committee, Fishermen Involved in Natural Energy, which was established by Lincoln County, and basically represented a broad spectrum of the fishing community, from charter fishermen through commercial fisheries. And as there'd been increasing interest in potential wave energy off the Oregon coast, the county wanted to establish a committee in advance of these proposals coming in, so that they could review wave energy siting proposals and then submit recommendations to the Board of Commissioners. So they wanted to be proactive. This was great for us because it allowed us to sort of connect with a broad range of the fishing community through one committee. And once Newport had been selected, we worked with the Fine Committee, provided them with a number of criteria that we had for our site. And then, this was before my time, but the story goes is that they got together, laid a chart out on the table, discussed it for 20 minutes, and then drew a box with a Sharpie on the chart and said, if you put the site in there, we're okay with it. And basically the shaded area in here is where PacWave South is located within that original area chosen by the fishermen. So once we had the offshore test site, a number of things kicked off. Our permitting process kicked off, which I'm not going to go into details about, but that was an extensive permitting process resulting in the BOEM lease and a FERC license. But on the technical side, what we started doing was trying to work out, now we had the offshore site, where our cable landing should be or could be. Basically, you have the offshore site, you have where you're going to bring it into shore, and then work out the cable routes in between. So we started off with a desktop study, trying to identify possible options along the coast. There are a number up near Newport, a cluster down sort of around this area called Ona Beach, and then down to Driftwood Beach State Park, where we ended up down to the south. While the site was sort of up here more to the north, you can probably see here that there's actually a rocky reef system offshore, which is particularly important to the charter fishermen. And it was suggested quite clearly that this was probably a good area to avoid. The one thing we did want to look at is that there was an old riverbed that had cut through that rocky reef historically and left a nice big gully that we had hoped to run our cables through. Unfortunately, once we actually started checking that out, it was clear that that wasn't going to meet our needs. One of the critical things we had to do as we were trying to work out where these cables were going to run is conduct a lot of surveys. We gathered a lot of geophysical and geotechnical data, both in the nearshore and offshore areas, but also on land, because obviously somewhere when you're running cables, they have to come onto shore somewhere. And your cable landing site, again, you need the data to support, in our case, horizontal directional drilling for bringing those cables ashore. So as you can see here, our survey work started back in 2014, and it continued through into 2022 and 2023, with final surveys being conducted by RTKC, who were the cable installation company. A lot of data gathered, side scan, multi-beam, sub-bottom data, gradiometer data, all of which critical not only for the permitting process, for the BOEM lease and other agencies, but also for the ability to bury these cables, which was critically important, both for protection of the cables and also to not impact ocean users. We also gathered a lot of geotechnical data. We did a number of cores, and more recently did a series of cone penetrometer pushes to gather data both along the cable route and also out at the test site. And as I mentioned, cable landing site, we did surveys across the beach, geophysical surveys across the beach, and geophysical and geotechnical surveys. at the cable landing site at Driftwood Beach State Park. And ultimately, what that gave us was our cable routes. This map is actually showing the as-laid cable routes, but all that information, starting off with your preliminary cable routes, gathering data, finalizing the cable routes, then gives you the ability to do a burial assessment, basically working out how well you're going to be able to bury those cables, what the seafloor conditions actually are. And from that, you get into what type of burial equipment you're going to use, and that then impacts what vessels you're going to need to support that, what the availability is of that equipment, and all those pieces that feed into developing your final cable installation plan of work. So now getting sort of into slightly more into the construction side of stuff. So we had sort of three phases of construction. We had the underground construction focused on the cable landing site, which occurred during 2021, 2022. I'm going to talk a little bit about that. We had the construction of the build of our shoreside facility that we call a utility connection and monitoring facility. I'm not really going to talk about that today. And then the largest piece of the project, the cable manufacture and cable installation, which started in 2023, and contracts are just closing on that. The actual work was completed late summer, early fall last year. So critical piece, the cable landing site. This is Driftwood Beach State Park, shown in yellow. We actually have conduits running to our shoreside facility just down the road. But the main piece of this work was the installation of 4 offshore conduits. These run from Driftwood out about a mile offshore to basically take the cables deep underneath the nearshore area, the high energy nearshore area. And you probably can't really see this on the screen very well, but with Driftwood here, horizontal directional drilling, allowing you to steer your drill head. Our team went down about 120, 130 feet underneath the seafloor, just over a mile, and then punched out on the seafloor in about 45 foot of water depth. This is the 2 companies involved, the major companies. The work was done by the HDD company out of California, and the engineering was done by Jacobs, primarily out of their Corvallis office here in Oregon. This photograph shows the state park at Driftwood Beach, the parking lot at Driftwood Beach. 2 very large horizontal directional drill rigs set up. We basically took over the park in agreement with state parks. We maintained pedestrian access, but otherwise we pretty much dominated what was going on in that area for almost a year. At ground level, this sort of shows the 2 drill rigs, and down at the bottom, it shows the conduit that we installed offshore. This was 10-inch thick-walled steel pipe, surplus from the oil and gas industry, and then custom threaded. Basically, we drilled the holes with the drill rigs and then pushed this conduit into the ground out to the punch outs offshore. Once those conduits were all installed, the next piece at Driftwood was building a very, very large splice vault. So we had the offshore conduits coming in on the seaward side of this, and then we had terrestrial conduits running to our shoreside facility, coming out on the side that you can see here. And then once that was all constructed as part of our agreement with state parks, basically we rebuilt the parking lot, made several improvements, including fixing stormwater systems and building a new viewing platform. So very large piece, even though it's not the cable lay piece of the work, was the underground construction. As I said, it took almost a year for this piece of work. Just over 6 miles of conduit installed, both the offshore and terrestrial, 1.2 million pounds of steel for the offshore conduits. So a significant piece of construction effort for this. And then moving on to the cable piece. This was led by Artie Casey out of Louisiana. We had, as you saw from the earlier map, 4 cables, 4 subsea and 4 terrestrial cables. And these were manufactured by a French company called Nexans, primarily in their factory in Norway, but some of the work was done in their factories in Switzerland. And on the end of these cables, as we're a test site and we're going to have wave energy companies coming to test their devices, they need an ability to connect and disconnect to our cables. So on the end of the cables, we have dry mate connectors, large connectors that will be pulled up to the surface. Developers can connect their device and their umbilical cable to those and then lowered back down onto the seafloor. Those connectors were manufactured by a company called McCartney in Denmark, shipped to Norway, where they were terminated onto the cables prior to shipping everything to the US. A few pictures of the what went on in Norway. This is the factory in Nexans in Norway spinning up one of our cables. This is the stack of our cables with RTKC's subject matter expert owner's rep standing on top of them with two of our subsea connectors. This gives you some idea of the amount of cable that we had, totaled almost 50 miles of subsea cable. And then one of the connectors here, or half of a connector, the developers will bring a mating half to join to that with yellow bend restrictors. The connector itself, we have Giovanni here as for scale, but the connector and the bend restrictors weigh about a ton. So to get the cables transported and installed, a lot of assets involved. The cables were shipped over from Norway on the freighter Frida. Basically, its job loaded up the cables in Norway and then brought them to Louisiana. In Louisiana, Port Fourchon, they were loaded on board the HOS Innovator, which was our cable lay vessel, which also installed some articulated pipe armoring, which I'll touch on, and deployed the subsea connectors, and also was involved in some concrete mattress deployment, which helped stabilize the cables in areas where we didn't get good burial. We also had a dive support vessel, and finally we had a cable burial vessel, basically, which was involved in, as I said, burying the cables underneath the seafloor, but also conducting the post-burial surveys. So this is how our cables got to the US. Departed Rognan in Norway, came down through around to Port Fourchon, Louisiana, where they were transpooled onto the Innovator. The Innovator was meant to leave beginning of July, but had to wait to avoid Hurricane Beryl as it was passing through the Gulf. And then headed down through the Panama Canal and then up to North Bend in Oregon, where operations were based. This is just a couple of seconds of webcam footage from the Miraflores lock, which is the final lock on the Panama Canal before the Pacific Ocean. And this is the Innovator, our cable lay vessel, coming through fully laden with our cables. And then last year, you know, as the Innovator was coming up from Louisiana, a lot of other activities were going on. We started off with the Liberty doing what's called a grapnel run, which was basically trying to remove any debris along the cable route. We also, as I mentioned, had the terrestrial cables. So we had a shoreside team back at Driftwood, partially closed down the state park. Started off working on the terrestrial cables, and then when the Innovator got on site, basically the dive vessel and the shoreside crew focused on the cable pull-in, so pulling those subsea cables in through the conduits into the vault at Driftwood, terminating them, and then the Innovator would do the cable lay. Once the cables started being laid, the cable burial vessel, the Nautilus, came in behind and spent about 2 months doing cable burial work. And once the Innovator had finished its cable lay work, it went and deployed the concrete mattresses for the secondary protection shown here. So we had started, end of the first week of July and finished, second week of October for the actual cable lay operations. So here's some pictures. This is the stack of cables actually aboard the Innovator. So we had 4 cables in total, as I mentioned, almost 50 miles of cables. 1 cable on top here with a connector lashed to the side, second cable, a second connector, third cable, the connector, or third and fourth, the connectors are below deck. There's a person standing here to give you scale, and a rather dirty cut-off section of the cable, giving you some idea of the size of it. Total cables, a little over 1,000 tons of cable. One of the things you will notice is this large gantry above the cable. This is basically, the cable will feed up through this and over the top of the gantry, and this is to prevent the cable from bending too much. There's limitations on the how much you can bend the cable, and this gantry allows the cable to be fed up and off the vessel without bending it unduly. This is a picture of the Innovator sitting off driftwood. The point here is that's driftwood at the background, in the background. So that gives you some idea of the lengths of the conduits that were installed. The conduit terminated just off the stern of the vessel here. The cables were then pulled from the Innovator all the way through the conduits, and I said terminated at driftwood. So just to briefly touch on some of the equipment, there's a lot of equipment needed for something like this. All the equipment labeled in yellow is associated with the lay of the cable. So you have the cable tank, as we saw before, the 4 connectors, the gantry, just as I mentioned, what's called a linear cable engine, which is used to kind of feed the cable off the stern of the vessel. A control tower where all that equipment is monitored and controlled, and then the chutes through which the cable runs offshore. We also have articulated pipe, which is some secondary armoring that we used in the nearshore area where we knew we had rocky seafloor and weren't going to get good cable burial. And then we had ROV support. This was a relatively small observation ROV with a manipulator for light work. So we had the primary ROV off this tower here, a backup ROV, and then the ROV shack running all those operations. And then critical for the operations was this 36-ton crane that was part of the vessel. So this is an aerial shot showing cable laying going on. You can see 3 people here standing on the cable. So you give, again, some idea of scale. The cable coming, looping up over the top of the gantry, running down the gantry, down to the deck, through the linear cable engine here. This is the area where split pipe's installed. Again, the ROV shack and control tower, and then the cable running off the stern of the vessel. And the yellow line is the tether to the ROV that's observing the touchdown of the cable on the seafloor. I mentioned the split pipe. Split pipe, it's basically a ductile iron clamshell that's installed by hand onto the cable. Slow and somewhat risky for the people doing it. It's very heavy. Each piece of that is extremely heavy to handle. But only we put that on for the first 500 feet or so of each cable coming out of the conduit. And then after that, it was much more straightforward cable lay, laying at, anywhere from 1,000 to maybe 1,500 feet an hour. Basically, once the cable was, you were doing the laying away, we did that until you got out to the test site, at which stage the subsea connector was picked up over the top of the gantry, which was an exciting maneuver, to say the least, at sea, and then lowered down to the seafloor where the ROV would disconnected the cable, the winch cable, and the subsea connector was deployed. And we repeated that 4 times, once for each of the cables. As I mentioned, once the cables were laid, the innovator was reconfigured for deployment of concrete mattresses to stabilize the cable. We deployed 30 of these in strategic places where we didn't get very good burial. And really the point of these 20 by 8 foot mattresses is to stabilize the cable, stopping it shifting around on the seafloor. We have a 25-year FERC license, so these cables are going to be sitting out there for a long time. Even a minimal amount of movement of the cables against a rocky seafloor is going to damage them over time. So these mattresses stabilize those. And this is a shot of the sonar from the ROV as one of the mattresses is being placed. You can see the cable here, and then you can see the frame of the mattress as that's lowered down. The vessel had dynamic positioning, so by moving the vessel and by adjusting the crane, you were able to maneuver those mattresses and place them as they were needed. And then the final piece of the cable installation was the cable burial. As I mentioned, this is the Nautilus. This was a Spanish vessel, came over for this job. And the Nautilus is the whole vessel with its 31 people on board was dedicated to the operation of this, which is the CMROV-3, which is a cable maintenance ROV, which was the machine that was used to bury the cables, place the connectors, and do the post-burial surveys. This thing's about 9.5 tons in air, 12 feet by 12 feet by 9 feet, a very large piece of equipment, very specialized piece of equipment. You can see it here, it's tracked. So most of the time what it's doing is tracking where the cables are and then using these swords, these jet swords, to jet down into the seafloor to allow the cable to drop down, and does multiple passes to get the desired depth. This is a picture of the control room for the CMROV, and again with sonar showing the cable trench. And then just this is the view of the screens they have. So looking forward underneath the ROV, the sonar, and looking towards the back of the ROV where the trenching's happening. Obviously not a huge amount of visibility when that's going on. So cable burial work was completed on October 13th, early in the morning. While the whole of PacWave, planning for PacWave and construction of PacWave went on for multiple years, the actual cable work was about 27 months from the time we contracted with RTKC through to completion of the burial. Cable manufacturing itself, about 19 months. In total, there were about 300 vessel days of charter, about 5,000 person days of work for the installation, and almost 1,000 hours of that CMROV on the seafloor, including the longest dive that ACSM, who ran the ROV, had ever done, of 138 hours of continuous work, so 5.75 days of those operations. So that sort of summarizes the cable installation piece. The cables are now installed. We're waiting to move forward into the operational phase of the project. Alongside all of this is also the required monitoring, which Sarah will now talk about. Over to you, Sarah.
Thank you, Dan. So seeing a few questions come into the Q&A, just as a reminder, if you have questions for Dan that are percolating, get them in there. And then if any questions arise while I'm talking, feel free to add them to the Q&A. So I'm going to talk about both our site characterization and monitoring at PacWave, give a pretty high-level overview, and then do a real focus on the benthos, the sediment, and the organisms living in the sediment along the cable route, as that most closely follows what Dan has told you about and is my area of expertise. But I do want to make sure to introduce all the work that we are doing at PacWave. So I've been the PacWave environmental studies that we are doing and have done, as we had what we called our site characterization period. And this is prior to getting our license. This is gathering data as we're preparing our license application, characterizing spatial and temporal variability and habitat characteristics, which might be physical ones, acoustic ones, and species distributions. Identify any species we didn't know were there before we submit our license application, and then take what we learn about the spatial and temporal variability to implement our, at that time, future pre-installation and post-installation surveys. Then we have those pre and post-installation monitoring that we are required to do because we now have a license to build a project and operate a facility off Oregon. And then as a faculty member at a university, I'm excited about additional opportunities for research in environmental questions now that we have such a great time series and presence at the site, and we can ask other interesting questions. So those that are part of our license requirements on the upcoming slides will have this little lightning bolt to say, we got to do it if we're going to generate electricity. So here is an overview of the many kinds of environmental surveys that we have been doing really since 2010. We started up north at the PacWave North site that Dan briefly mentioned in 2010, and then started sampling the PacWave South site in 2013. And so we've done benthic invertebrate and sediment grabs, trawls for flatfish, wide variety of seafloor videos. We've put out Dungeness crab pots. We've observed birds and mammals and deployed hydrophones and mapped the electromagnetic fields and done some lab studies. So this is the suite of activities that have taken place at the PacWave North and South sites. I mentioned I'm going to focus on the benthic invertebrates. So at this point, I'm going to work from the bottom up and just highlight some of those other things before we take a deep dive into the benthos. So Dr. Adam Schultz is our EMF expert here at Oregon State University, and he has put out his EMF measuring devices, which please don't ask me any questions about how they work. That's really Adam's domain, to map what does the ambient electromagnetic field look like at the site. That way we can have a reference state to compare once devices are installed. We've also done some laboratory studies looking at particular species of interest in the lab, and we have given a webinar on that before that maybe is accessible. When it comes to putting devices in at the site, we do have a license required EMF modeling and monitoring plan. Here is a figure showing electromagnetic or magnetic field strengths around many other existing cables. So at our site, once WEC devices are committed to be deployed, we will run models to estimate the anticipated EMF output associated with those WECs that are built to supposedly generate a certain amount of energy. And then after those WECs become operational, we'll conduct field surveys to validate the models and see if they're operating the way that we modeled them. And then we have an off-ramp for our EMF monitoring that says if the field monitoring from our first 8 WEC tests indicate that our models are aligning with our measurements, then we can stop doing field measurements unless we get a much more powerful WEC in there. In terms of noise, we have, as I mentioned, over the years, put out different types of hydrophone landers. So we have over a decade of ambient noise data from the north and south sites. And then once we might do activities, we will have peripheral passive acoustic monitoring, that's what PAM stands for, deployed on the 4 corners of the area. We have put them out now that we are in this pre-operational phase. We also have another passive acoustic monitoring system, but with real-time reporting that we will deploy. We have deployed it to test it, but that will be deployed when we have devices in the water that can do real-time reporting of any noise exceedances. And then we have a drifting passive acoustic monitoring system, which we will rapidly deploy right after we install a WEC to get sort of the noise signature of that device, so we know what that will sound like on both our crab and our peripheral PAMs. And then again, if our real-time systems indicate an exceedance, we can rapidly deploy the drifting system and get some more high resolution data from that. We've done over the years, pretty much anytime we've gone out for some other type of survey, we've had bird or marine mammal or both observers on board. So we're generating a large data set of mammal and bird observations in the area, which we will continue to collect with our additional monitoring that we will do at the site. And so I just pulled for you one figure of sooty shearwater densities at the site over different seasons. And so we will continue to take those sorts of data. We sampled crabs using crab pots, and what's highlighted here are, we had 6 sampling stations, and the deeper station on our PUD line is the one closest to the site, and consistently, almost always that was the station with the fewest crabs in our 2 years of site characterization studies. And so I think that gave reduced some anxiety that this might be a crab hotspot that we were taking away. It actually seemed to be a crab low spot within the area. So that was nice to be able to provide those data. We will, once we have more structure in the water, be doing surveys using video methods, pictured here on the left. We've got a mini ROV that we use to survey some installations we had at the PacWave North site. We have a video lander. This one, at the moment, the cameras are set up facing down to look at the seafloor, but we can change those to be facing out to look at, for example, the anchors like pictured in the bottom left photograph. And we've also been investigating the use of different kinds of autonomous vehicles that use sonar and maybe some visual cameras on them to see how effective those might be to survey the seafloor and surrounding organisms around the installation. But our license requirement is to do the ROV surveys, and then we are experimenting with different other visual techniques as opportunity arises. All right, and then to the top of my list is our sediment and benthic invertebrate visualization and collection. So we have been sampling the PacWave North site since 2010 and the PacWave South site since 2011 using this box core method. It's super low tech, very reliable, only mechanical, no electronics. We just drop it down. It's got an unstable trigger on it. When it hits the seafloor, the jaws close and bring up a sample of the seafloor. And so we can analyze the sediment for grain size, total organic carbon, or if we wanted to, any other sorts of chemicals. After we take a sediment subsample, we sieve the collection and identify fauna in the lab. We've also been experimenting with using a sediment profile image system. It gives a sediment profile image where a prism is dropped down and it actually goes into the sediment, and then we can take pictures of the sediment. We've also got a plan view camera on there that can take a picture of the surface sediment, and Integral Consulting is developing an automated interpretation software where we might be able to actually see sediment patterns without disturbing the sediment by using the box core. So that is area of research, but the traditional grabs that are the same grabs that have been used for decades for sampling dredged material disposal is what our license required sampling is for this set of habitat and species. So some few lessons learned and observations from our PacWave North site, which, as I said, we've been sampling since 2010. The benthic community at 50 meters depth is really a transition community. So what this plot is showing is a number of different samples taken at different depths, and dots that are closer together are more similar in the species that are there, and dots that are further apart are more different. And you can see on the lower left that samples from 30 and 40 meters are clustering together. On the right, samples from 60 and 70 meters are clustering together, and then at 50 meters, they sort of span both the shallow and the deep water community. And what we also showed is that we have a real break in the wave base index at about that same depth. And what that means is the wave base, in simple terms, is how deep the waves are influencing the bottom. So at what depths do the waves influence the bottom? And so rarely off Newport do waves influence the bottom when the bottom is deeper than 50 meters. Frequently, they influence the bottom at depths shallower than 50 meters. So we see this transition in the wave conditions and a transition in the benthic community, which is important for us to know as we embark on a project to extract wave energy. Some other things that we learned from PacWave North when we had one device testing up there is we saw, as one would predict, some scour around the anchors. We also saw an accumulation of a lot of shell hash, which I still have a lot of questions about. Those aren't shells that might have grown on the anchors or devices and fallen off. Those are long dead shells that either have been excavated or accumulating around the anchors. So some interesting patterns there that we were able to learn from our north site. So what's going on at our south site that Dan covered so extensively? So in 2013 to 2015, when we were in our site characterization phase, you can see I took box score samples all over from PacWave North down to south and through where our cable routes would be, to look at overall spatial and temporal variability in the area. Again, what are the scales of variability? Here is the stations plotted, and the shape and the color of the symbol indicate similar groups. And so what we could see right down here at this 50-meter line is that they are unique from the 30 and 40, just like we saw at PacWave North, and 60 and 70 are quite similar, but these 50-meter stations are quite different. And it's important, as we start thinking about what the consequences are of cable routing, to know that we should expect there to be differences here, through here, and then up towards the site. So then we were doing a lot of paperwork and not required to sample anything until it was officially our pre-installation year. But as a marine ecologist, I couldn't let those years in between go. So we had some additional opportunistic sampling from 2019 to 2022 to keep the time series going, and just so I could track any long-term trends prior to project kickoff. And then 2023 is the official beginning of our license required sampling. And so all of these stations you can see we're sampling along the cable route, in the site a lot, just trying to get a really good baseline of what does this site look like before we actually started any in-water work. And then I've got some going and visiting the north site, just keep my eye on it. And then in 2024, in yellow was a pre-installation survey, and then everything that happened with the cabling that Dan talked about happened. And then in October, I went out and again sampled along the cable route in the fall. So looking at pre-installation benthic invertebrate patterns, if we just take what we caught and divide it into major groups, what we can see is that the crustaceans, which would be amphipods, shrimp, maybe some little crabs, and the bivalves, and bivalves are like small clams. These three lines are the 3 different seasons of sampling. And so our blue line is fall, our green line is summer, and the red line is spring. And in both cases, the pattern from near shore to offshore is consistent across the seasons, but with some differences in abundances, but not statistically significant. All these gray shadows are overlapping. Contrast that with the worms and the snails, that their pattern with depth really varies from season to season. So we've got worms that increase as you go offshore in the fall, but decrease as you go offshore in the summer, and similar with the snails. Echinoderms generally decrease with depth, except in the fall when their densities were quite low and consistent. This is 0. And then similar with cnidarians, those are like little sea anemones, also decrease with depth, but only during the summer because they shouldn't be there in the fall. And so for these communities, these different sets of organisms, it'll be especially important if we're trying to look at potential impacts to compare like seasons. So only appropriate to look at fall post-installation, so fall pre-installation. And then maybe also we might as well just stick with it for our crustaceans and bivalves, as they seem to have the higher abundances overall in fall. But the pattern with depth has remained consistent. All right, so here's our, and you are the first group to see this post-installation data. So these are hot off the press and very preliminary, but we're sharing them here today. So when we look at the sediment that we sampled in fall 2024, and then again, or in 23, and then again after the cable laying in 2024, no difference in median grain size. This is median grain size on the x-axis, our near shore to offshore on the, or that's y, this is x, and no difference. There's so much variability. And these are, I just down selected here, the stations where we went back to the exact same spot. If I plotted all the stations, the variability would be even greater. So this is trying to look at just the exact stations where we hit before and after. In terms of the animals, again, overall, no statistically detectable difference in any organism group. So we could just stop there and say there's no differences, but it's fun to explore some patterns that you see. So the crustaceans, they look pretty much exactly the same. Bivalves, completely overlapping confidence intervals, but actually a few more post-installation, and same with the snails. So no declines of organisms after the cable laying experience. These two are really interesting. The worms, we had a slightly stronger response to depth in 24 after the installation than we did before. Not sure if that means anything, since statistically they're not different. And same with the echinoderms, really the sand dollars are what we're talking about here. So some next steps, we need to identify all of these bivalves and snails and worms down to the species level, which is underway. And then we can compare things like richness, how many total species, species diversity, and then track individual species we would be hypothesize might be more likely to be impacted by sediment disturbance. So, for example, here are 2 of my favorite bivalves, little clams, because they do seem to be indicators of certain conditions. So this one on the left, Axonopsida serracata, it doesn't care what sediment it is in. I have found it everywhere. You can find it in Puget Sound. You can find it in coarse sediment off Newport, but it is only found deeper than the winter storm wave base. It does not like to be disturbed by waves. So that's something we wouldn't expect to have changed yet with our cable installation, but maybe someday when we're talking about removing wave energy from the system, we could keep an eye on it. Whereas this other friend here on the right, Nutricola lordi, it's only found in clean sand. If there's any silt, you don't see Nutricola, it's out. And so that is something that maybe if you are disturbing the sediment, you might expect to see changes in. So I'm excited to finish identifying those samples we took in the fall down to the species level and see if we can see any changes in individual species. And of course, we're continuing to survey. So we are sampling this spring, and then this will allow us to compare to spring 2024, which was before installation. And so far, I've sampled all the white dots and have 4 more cruises on the calendar to finish out the cable route sampling later this month, the pink dots. And then we will sample within the site because we hope to have wave energy devices next year. So this spring would be our it's our post for the cable route, but it'll be our pre-installation for within the site if devices get deployed next year. So with that, I will say thank you. And I believe it is now time for our Q&A portion.
Thank you so much, Dan and Sarah, for such informative presentations. Like Sarah said, we're going to open it up for questions now. If you've got a question, please put it in the Q&A section on the Zoom. I'm going to start, Dan. There's a couple quick questions for you related to specifications. I'll list off kind of a series of questions we've got, and then we can take them one at a time if you'd like. So the questions that were asked are, what was the insulation type used on the cables? Was the conductor copper or aluminum? And if copper, why was this material preferred? What diameter were the cable cores? And how many fibers and auxiliary cords? And what length is unburied at the connector end? And what radius can the connectors be moved for connection? So we can take them all at once if you want, but the first question is just, what was the insulation type used on the cables?
Yeah, so the cables are XLPE insulation, 133%. I had to look that up because I don't have that information right at my fingertips. But yeah, so that's the cable insulation, pretty standard for subsea cables, I believe. While our cables are made in Europe, the main reason that happened was not that they're particularly specialized cables. They're actually relatively small cables compared to would be used for offshore wind for larger projects. But it was also making those lengths of cables with as few splices as possible. I'm looking at the questions here. The other question was on the conductor type. So they were copper conductors. And most of the subsea cables for this type of application are copper. For us, there was a couple of reasons for that. The density of copper actually helps the cable settle better into the trench when you're burying it, which was important. And aluminum conductors, the cables would have been a lot bigger. And one of the issues we ran into was for the HDD, installing the conduit, we had mile-long conduits, and that's a very long pull to pull your cables in. So if we'd gone for our cables, I think a 3 3/4 inch diameter, maybe a little over that. If we had gone for bigger cables, we would have had to upsize the size of our conduits, which would have meant more horizontal directional drilling, and the costs just sort of escalate on that.
The last question, I think, was about what length is unburied at the connector end, if you know.
Yeah, so we have about 300 meters of cable unburied on the seafloor at the test site. There's no sort of magic number there. To pull that connector up to the surface, you want a minimum of 3 times water depth. And I believe there's another question about water depth, but at the site we're 65 to 78 meters depth, so that's 200 to 250 foot. And I'm jumping sort of between metric. So we went for about 1,000 feet of spare cable sitting on the seafloor, and part of that is if there's any water intrusion into the end of the cable at the connectors, which the connectors are probably the most experimental piece, and I use that term slightly loosely, but subsea connectors don't have a huge history of usage like we're putting them to So there is chances that we would get leakage there. And having extra cable just means we have the ability, if we need to cut back and resplice. So yeah, about 1,000 feet of cable currently on the seafloor at each of the sites.
Thanks. Thanks for those detailed answers. Sarah, I've got a question for you. For the pre and post comparisons of life, were these with the cable energized or dead? And would it be interesting to look at both versions?
It absolutely will be interesting, and we will do it. Those cables were literally still being installed as I was chasing the install vessel to take my samples, because by about October 13th, we're all done on the water. So, yeah, they were quite fresh when they were sampled this fall. As I'm going out this spring, we expect to see a lot of recovery of the sediment around them, but they're still not live. That will have to wait until we have devices, which will hopefully be next summer.
Great. Another question for you, Sarah, is what's the maximum and minimum depth of the sample test area?
So the water depths in which I've been collecting my samples, I think the shallowest one, trying to get as close to what we call the punch-out locations, where the conduits turn into the trenches. My shallowest samples were from 18 meters water depth, close to the punch-out locations. And then I've been sampling, all along the cable route. If people notice, the cables kind of wrap around the backside of the site and come in from the west. So all the way out to like 80 meters water depth to get to those. If the question is how deep into the sediment the samples are from, typically at the PacWave site, the sediment there is quite coarse, medium to large grain size sand. And so the core does not penetrate very deep. We're looking at like 10 centimeters max penetration of like going down and grabbing the sediment down to about 10 centimeters.
Dan, I've got two questions for you related to permitting and regulations, and I know you didn't cover this in your presentation, so feel free to answer as you'd like. One question is whether there were any challenges associated with the Jones Act.
That's, yeah, a very good question, and something that was very much on our minds. So when we contracted with RTKC, who were in charge of the cable installation, that was the one of the critical things was Jones Act and whether we were going to need to get waivers and so on. All the the innovator that was used for the cable installation is Jones Act. It's a US flagged, US built, US operated vehicle, so vessel. So it was fine with the Jones Act. The freighter that brought the cables over to the US was simply bringing, it wasn't port to port, it was just delivery to the US. So no, we actually didn't have any issues with the Jones Act because we strategically used vessels that were compliant.
And you alluded to this in your answer, but for those who aren't familiar, would you be up for giving a really brief explanation of what the Jones Act is and how it might relate here?
Yeah, so as long as there's no attorneys listening to it. So basically the Jones Act looks for this type of work to be using US flagged, US built, and US crewed vessels for basically I think it's officially transportation of goods between ports. But because we were going port to port and installing the cables, we would have had to comply with the Jones Act. If you run into it with some of the specialized vessels that have to come from Europe to try and do work in the US and so on, particularly around offshore wind and so on, you have to try and get waivers for that because there aren't necessarily US flagged vessels that can even do that work. So it's just, one of the other things that you have to take into account. Luckily, we didn't use a dedicated cable lay vessel. There are some vessels that are designed and built only for cable lay activities, cable lay and burial. we used a standard offshore work vessel that then equipment was fitted onto it to allow it to lay cables. I think there are a couple of maybe one or two US flagged cable lay vessels, maybe just one. Most of them are foreign flagged. So when you try and do cable installations with a dedicated cable vessel, you frequently need a waiver from the Jones Act, and you can get them. It just takes, I think there's a time impact from that.
Thanks. That's a really helpful overview for people who aren't familiar. One other question for you, Dan, is was the footprint for the HDD onshore landing the same as the parking lot? I think kind of related to that, was the park helpful in the permitting process in light of the fact that they were an active partner or proponent in the project?
Yeah, so start off with state parks were fantastic partners. I must admit, when we were first looking for a cable landing site, Driftwood State Park was one of the options, and they said to us, please, 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 if you can not use the state park, that would be great. Simply because it is it's a recreational park, it's for public access and so on. And we tried very hard not to use Driftwood. We put in offers on nearby properties and so on, but we were very limited for various reasons. So ended up in the park. Once it was clear that we were going to use Driftwood, then parks were an active and critical partner in that. We did maintain pedestrian access, but we took over the whole of the parking lot. We basically wanted to remain within the footprint of the parking lot for all sorts of issues, for permitting issues, for lack of impact on surrounding vegetation and so on. So that was actually, we designed the HDD setup to fit within the footprint of the parking lot rather than that was really the limitation. We wanted to try and stay within the hard surface areas, the parking lot and the sidewalks. Initially, we thought we had a ton of space, and then they started bringing the equipment in. And once you got all that equipment in there, you realize that parking lot suddenly is not a lot of space to operate. But that was one of the requirements for the HDD company, is you guys have to fit within the footprint of the parking lot itself.
Sarah, I've got a question for you. Question is, are there currently any efforts through the Pacific Marine Energy Center to understand community perceptions of the environmental effects associated with the cables?
Let's see. I would say not specifically that question. We do have a number of projects at PMEC looking at community perceptions of wave energy in general, also offshore wind. The wave energy, we've done surveys and interviews over many years because the project has been going on for many, many years. So we are definitely, it's been really exciting to see how community perceptions of wave energy are changing, now comparing perceptions of wave to perceptions of wind. I think that would be great to have some specific questions about community perceptions of the environmental effects of the cables. So yeah, great idea.
Dan, a question for you. Did the sea state ever prevent or delay work, either for lay or burial? And if so, what were the specific conditions that hindered work?
Yes, it did. So, weather was really one of our biggest challenges, potentially. The weather window in Oregon, probably you can't really start doing this type of work until May at the earliest. And, come the beginning of October, the weather can just go, that can be it. October, sometimes October will be beautiful. Other times, October 1, you can't get out there again. So, limits on weather conditions, sea states and weather conditions were really significant. We tried to fit the cable operations into a weather window. We actually hoped to start like July 1, and there were some delays at the factory in Norway. Some equipment failed, so we didn't start our cable installation work and the actual lay of the vessel until beginning of August. And we were nervous because with a cable lay vessel, a cable burial vessel, a dive boat, and a shoreside crew. I'm not going to tell you what the standby rate was for that, but it was an enormous amount of money. And then we did have limits on the sea states for some of the operations, dive operations. Obviously, there's limitations getting divers on and off the boat. The cable lay, once you're actually doing the lay of the cable, there's a reasonable amount of flexibility. Probably the biggest challenge weather-wise was when we were trying to lift those connectors up, and we had to lift them up about 90 feet above the deck to get them over the gantry and down onto the stern and deploy them off the stern. We were generally looking for less than 4-foot seas for those, and that's really challenging in Oregon. And we had that at times, and then we were in the middle of deploying one of those connectors, and we just got hit by a series of 6-foot seas that sent the thing swinging, and we had to lower it down, rest it, and all the rest of it. Through experience, we had a cutoff, an official cutoff, but when in reality we did things like reposition the vessel, so we were stern into the seas as much as possible. We couldn't be bow in for the way we were laying it. And as the crew, repeated this process, things got tighter and tighter. You got a better handle on things. So there was a little bit of greater flexibility in it, but it was definitely one of the major challenges that we faced.
Absolutely, out in Oregon waters. Sarah, were there any sea state impacts for your research? And if so, is that something that we might need to be thinking about for monitoring?
It is challenging for me to get the number of samples that we committed to in the license. Because, yeah, I mean, an ideal day at sea, I can get 20 samples, no problem. But those days are few and far between. And so, like, my cutoff is 7-foot seas. Just if you're trying to do the box score, it's got to grab the bottom. So if the boat is doing this, it does not grab the bottom very well. But the number of days that we go out and still get kind of skunked, because the other thing it has to do is it has to hit the bottom square. And so if the current is running one direction and the wind is pushing the boat in the other direction, then the box score is hitting at an angle, and it's just failure after failure. And then finally we say, okay, let's go in and try another day. So yeah, it is Oregon, and it is challenging. So it's a consideration for planning monitoring activities, but also recognizing that a fall sample truly has been taken in fall, because it's like those 50 samples were taken over like many different days at sea where we were successful in actually grabbing them. So some variability even within a season.
And if I can just follow up on the weather conditions, one of the things we had when we were doing the cable lay is we had 2 wave rider buoys out at the test site, and we had basically live data coming in from sea conditions. And it's one thing to have a cut off. You say, 7 feet, but you can have long, slow 7 feet is very different to short, choppy 7 feet, and which direction the current's running or the wind's blowing and so on. So really, it's a matter of getting out there. When you believe there's an opportunity, getting out there, and you can find a window. We had one time we were trying to deploy one of the connectors. The weather looked really not very cooperative. So we were sitting there laying cable at like 10 feet an hour just because you have to keep it moving. And actually, Burke Hales, who's the chief scientist at PacWave, does a lot of recreational fishing offshore. And he said, and he's an oceanographer, and he looked at the weather and he goes, I think there's going to be a 4-hour window this evening. And that's what we needed. And, evening came and there was no window, but midnight, it suddenly dropped and we got a 4-hour window. I was fast asleep. The project manager woke me up, said, we're going, and we jumped in and did it. But, it's being on site, waiting for those conditions. And it's really just making that decision based on the conditions at sea rather than, a number for sea state or wind or anything else.
Dan, we've got a question regarding the operational phase. What are the anticipated testing plans and the timeline for that?
So yeah, we have 4 developers currently lined up, funded by Department of Energy to come in and test. The plans are currently for them to come in next year, and most are looking at generally these guys, and generally I think most developers will be looking at 2-year deployments. Will be pretty standard. Some may be a bit shorter, some may be a bit longer. But we expect the first developers to be coming in, late spring, early summer of next year, and be out there for, probably at least out in the water for 18 months. Again, they have to look at, seasonality for when they're going to be able to get their device and their equipment out again. And ultimately, if we have other developers lined up to come in the next year, we need a developer to get out in time to have the site available for the next one. So there's going to be lots of shuffling going on with that. But again, working around the weather windows, I think that's probably going to be the general plan for testing.
Great. And a question for either or both of you. Were tribes involved in the initial site selection?
The tribes were consulted, we had tribal representation, I believe, on the committees that were put together by Reedsport and Newport. But I don't think they were particularly involved in the site selection itself. That was mainly from the fishing community.
I have another more technical question for you, Dan. An attendee commented that they thought you showed clamshell pipe protecting the cable and wanted to know, if so, why there would be a concern around pulling a mile through conduit.
So that split pipe that was installed once the cable was pulled through. So the cable was taken off the ship, pulled through into the conduit, and based on the measurements of the length of cable that had gone off the back of the boat, they knew when to start putting that split pipe on, so that when it was pulled in, it was pulled in right up to the end of the conduit. But they're trying to measure to like the inch for that cable that's been pulled in. So it's quite an art to see them do it. I'd never come across this before, but they got the beginning of that split pipe to within about, I think it's within 2 feet of the end of the conduit, which is exactly what we needed.
And Sarah, a question for you. Do you expect to use mostly floating on surface or midstream tethered devices due to lack of interaction with waves below 50 meters, or do you still get enough tidal flow towards the seabed to test seabed mounted devices? Let me know if you want me to repeat that question.
I think the question is asking about the actual wave energy capture devices. And so most of the developers that we are in conversation with are looking at testing wave energy devices where the wave energy capture portion of the device is on the surface and then moored to the bottom. So we're not looking at tidal flow. There are some types of wave energy devices that are seafloor mounted, and most of those are achieving energy production by getting the pressure differential between like a wave height and a wave crest. So those need to be deployed in really shallow water, so that differential between the wave height and the wave crest is a greater proportion of the total amount of water. If you deploy those really deep, the difference isn't much. So those would not be appropriate for our site that is at like 70 meters offshore, or 70 meters depth, 12 miles offshore, 12 kilometers. So the short answer, yes, mostly surface devices.
And Dan, an attendee asked how you got from the parking lot to the yard and whether it was via horizontal directional digging or dig and bury.
But yeah, I think between our the Driftwood Beach State Park and our shoreside facility, we did that through horizontal directional drilling as well. We did that slightly differently. So for the offshore bores, we did 4 separate bores, and then installed conduit for the terrestrial bore, which was 2,300 feet. We did one very large or larger bore, like 28-inch diameter bore, and then put a bundle of conduits into that. Slightly different. And actually for that one, which is not uncommon for horizontal directional drilling, but because we were shore based on either end, they actually did an intercept bore. So they bored from both ends and then met about 60 feet underground, the holes intercepted. It's quite a common way of doing it. It's quite remarkable that they can steer these things and hit a target this big, 60 feet underwater, underground, 1,000 feet away from where they are, but they can. But yeah, so again, HDD for that piece. We did look at running out along the highway, but there was lots of issues with a lot of utilities already installed along there, and yeah, there are all sorts of issues that actually made it a lot more complicated.
Great, thanks. And I've got one more question for you all, but if anyone else has questions, please feel free to put those in the Q&A. So for either or both of you, we've got several related questions about energy costs. An attendee inquired about the cost of this energy to consumers, and then for consumer costs plus government subsidies. Attendees also asked how this cost compares to gas, nuclear, or wind, and about how the cost of energy generation will change over time, e.g. for this first-of-a-kind project versus further down the line deployment. So could you give us a quick overview of what is known so far regarding these sort of cost comparisons, if you have that information?
So much like solar was and wind was to start off with, wave energy to start off with is going to be extremely expensive. It's not going to be it's not going to be comparable to more traditional energy generation. And that's partly because at the moment these devices are one-off devices. Some of them, I think one of the developers said, it probably takes them $20 million to actually get a full-scale device in the water. So while this technology matures, while we get a convergence of technology, there's lots of different ideas out there at the moment. There's very few places in the world where you can actually test, which is why PacWave is being developed, is so that the designs can narrow down to one or two or a handful of designs that are shown to work, and then those start getting mass produced and more commonly deployed. Costs will come down. We generally say, and we keep saying this, but wave energy is probably 20 years behind wind. We're hoping to catch up, but if you think what the costs of, say, wind was 20 years ago, it was very, very expensive, and now it's absolutely cost comparable to other forms of generation, if not cheaper. And one thing you don't have with these renewables is subsidies. They haven't got the subsidies in place like they do with some other forms of energy production. So wave energy's got a way to go, but part of it is it's not going to make progress until you can start getting devices in the water and start working out how this technology can actually work and be successful.
I think I'll just ask you both a final question. What's one of the key things that you learned, and what are you thinking about for next steps, for future research questions?
Sarah?
Oh gosh. I think so. Just in terms of marine ecology, from a perspective of a marine ecologist, this project has really enabled us to pay attention to a marine environment that has not previously really been well characterized, right? There's a lot of studies in the intertidal, and that's because you can walk down there when the tide's out, so that's understandable, right? And a lot of studies of kelp forest systems, coral reefs in terms of if you're thinking about benthic ecosystems, but not a lot of global research on soft sediment, sandy bottom, flat-ish habitats. And so it's exciting to be doing this kind of work in an area where like almost anything that comes out of it is new. Like the little clams, you know, are all the little clams the same? No, not all the little clams are the same. They each have their own preference. And the question now, so I didn't show the third clam in that little story, but there's the one clam that like doesn't like silt. It's not going to be there if there's any silt. And then there's this other clam that only will be in an area if there's fine sediment in there. And so, but does that mean anything, right? Like, should we care about that? Does it, right? Does that scale up? Do the fishes care if it's like this clam versus this clam? And so a lot of like new information and exciting stories about animals in a habitat that's relatively understudied. And there's, you know, a lot we can learn from an ecology perspective. And I'm just so grateful to be in a position where I can like make ecological discoveries, but also, you know, move us towards a more sustainable energy future. So it's great.
Yeah, I think there's, you know, PacWave's focus is on, you know, helping developers test technology. However, what we are going to have when we have devices in the water is a really unique facility, and it's really why PacWave is so closely affiliated with PMEC, is the research opportunities that are going to go on. You know, there are countless different directions and research that can be conducted when you have basically what is this living lab offshore with OSU, you know, Hatfield Marine Science Center and so on onshore. Just lots and lots of possibilities and opportunities as we move forward. And while our focus is, you know, PacWave's focus is on the testing piece, we absolutely want this to be used as a research facility for people to be coming in and making new discoveries, whether it's on the technology side or the benthic side or you name it. You know, it is really a unique opportunity to try and answer some of the questions, and hopefully in doing that, you know, help streamline the process, the permitting process, as other, you know, deployments of devices sort of move ahead elsewhere, you know, in the US and in the world. It's just the more data we have, the more research that's done answering these questions, the easier it is to make good decisions about, you know, deployments and managing them and what needs to be done, monitoring, etc. So there's huge opportunity here.
Absolutely. Well, really exciting work that you've both been doing. Thank you so much for sharing. And thank you for our backstage crew, and to everyone who joined us today. For questions, if you've got questions about PacWave, please contact Sarah or Dan. We'll put their emails in the chat. And our team here, you can contact us if you've got questions about POWC, the Pacific Offshore Wind Consortium, sorry, acronyms. And we'll also put that email in the chat. Lastly, I just wanted to announce that we are going to be releasing a report later this week on environmental permitting for port development in California, with a focus on staging and integration for offshore wind. That report will also be the topic of our next webinar, with a date to be announced shortly, so you can look out for more information on that. And thank you again, Dan, Sarah, and everyone for joining.
Thank you, Aubrey.
Thanks all.
Thank you, all the attendees, and great questions.
Yeah, thank you.